Okay, so we're going to run through the solutions to the recent November exam, and I'm going to go right down through every question that we've been posed, all the way down from question 1 to the end. You may watch this in several stages if you wish, if you find it too long to go in one go, or just focus in on individual questions that maybe you feel needed more attention, or maybe lost a few more marks than the rest of them. So the first question we have, question 1a, is an inequality. Now, notice that it's a fractional inequality, what we would call a rational inequality, okay? The problem with this inequality is that although we follow the rules of algebra, which says clear all fractions, we cannot just simply multiply across by x minus 1, for the very simple reason that we have no idea what the value of x minus 1 actually is. It could be positive, therefore the sign will stay the same, but just like that it could be negative also, which means the sign would have to flip. So what we have to do when we're dealing with rational inequalities, or inequalities that contain fractions, is we have to multiply both sides by the square of the denominator. Now, why do we do that? Because when you multiply across by the square of anything, that means that you are multiplying across by a positive term. Every square becomes positive. Squares of all negatives are positive, squares of all positives are positive, so therefore when you multiply across by a square, it means you're multiplying across by a positive, and you don't have to worry about the position of the sign, okay? So that means we get 2x plus 1 over x minus 1, less than or equal to 1, both being multiplied by x minus 1 to be squared. Now straight away you can see what that's going to do. It's going to give me a quadratic equation in x, okay? The x minus 1 there cancels with one of those up above, and that leaves you with x minus 1 times 2x plus 1, which I'm going to multiply out now. That gives me 2x squared plus x minus 2x minus 1, and that in turn is less than or equal to, and again square the binomial, x squared minus 2x plus 1. So all I've got to do now is gather all terms to the left hand side. So I'm going to subtract x squared from the right hand side, which brings that down to x squared. I'm going to add 2x to the right hand side, which is going to bring this, if you notice both of these can go together, plus x and minus 2x, so that's minus x. So I'm going to add on 2x to both sides, that will bring it up to plus x. And then I'm going to take away 1 from both sides, so that's minus 2. And that in turn now is less than or equal to 0. So all I have to do with that quadratic is either fill it into the minus b formula if you wish to skip the factorization part, or just factorize x by x, 2 times 1, and that's a plus 2 and a minus 1. So therefore the results, as we appear to see, are going to be x equals 1 or x is equal to minus 2. Now because it's an inequality, they both have to be placed on the number line. So we put them on a number line, smallest one first, so minus 2 first, and 1 up here, and we realize that 0 is free for testing. Let me just change the color here. So 0 is free for testing, 0 is going to be roughly here, which means now I take 0 back to the original inequality, all the way back to the very top, and I put 0 in for x. Then that's going to give me 1 over minus 1 should be less than or equal to 1. And obviously when you divide 1 by minus 1, you're going to get minus 1 is less than or equal to 1, which is true. So therefore we are working inside minus 2 and 1. However, and I hope you notice this, one of the conditions on the question is that x is not allowed to be equal to 1. So therefore what that means is when we go to fill in this number line, we have to give 1 a circle, minus 2 gets a dot because minus 2 is allowed to be included, and then we shade in between. And how do I write that down? Well, I can write that down as minus 2 less than or equal to x, which in turn is less than 1, because it's not allowed to be equal to 1 as per question. Okay, solve the equation. X plus 1 over x equals 10 over 3. Here we go again with fractions. You clear fractions at every single chance. So to clear the 1 over x, I'd have to multiply by x. To clear the 10 over 3, I'd have to multiply by 3. So to clear both denominators at the same time, I'm going to multiply this 1 plus 1 over x equals 10 over 3. I'm going to multiply all of these by 3x. Now, what does that do? Well, that simplifies matters. It clears the fractions, as we expect. First of all, 3x by x is 3x squared. Now, in this fraction, the x there cancels with the x, and 3 ones are 3. And that's equal to 3 cancels with 3 to leave you with 10 times x, which is 10x. And that becomes the quadratic 3x squared minus 10x plus 3 is equal to 0. Because remember, to solve a quadratic, all quadratics must be set equal to 0. So you've got to clear either the left-hand side or the right-hand side. In this case here, we clear the right-hand side because it's easier to bring the 10x over to the 3x squared. Now, again, open your brackets or go to your minus b. Doesn't matter. 3x squared is 3x by x. And then I want to distribute the factors of 3 in such a way that the outside terms and the inside terms give 10. So 3 3s are 9, and 1 times x is 1x. 3x and 1x is 10x. So both of those will be a minus. And that tells me x is equal to a third, or x is equal to 3. Okay, so there are your two answers for that one. Next one. Now we've got to simplify. A lot of you in this question here forgot the golden rule about algebraic simplification. If anything contains a power higher than 1, you can see if it can be simplified by factorization. So if I was to take this as it stands, x squared minus 4, that's the difference between two squares. So that becomes x plus 2 and x minus 2. 3y squared plus y on the bottom has y in common. So that becomes y by 3y plus 1. X squared plus x minus 6, that becomes x and x, 3 and 2, and I want plus 1 in the middle, so plus 3 minus 2. And finally, the cubic expression. Look at what they have. They all have y in common. So it becomes y by 3y squared minus 2y minus 1. Now, when we're factorizing, knock out what you're not using so you don't get confused. This quadratic here, the 3y squared minus 2y minus 1, that can be further factorized into what? 3y by y. And I want to distribute factors of 1 to both, but I want to get minus 2 from the outside and the inside terms. So that's what we have left. Okay, now that we factorized, you start to cancel either vertically or, because it's a multiplication, horizontally also. So x minus 2 cancels with x minus 2. 3y plus 1 cancels with 3y plus 1. Y cancels with y. And what are we left with? We'll scan the top. The only thing we're multiplying now on top is the x plus 2 by the y minus 1. And on the bottom, the only term left is x plus 3. And that's the question. That's it. Okay. Next question. Solve the simultaneous equations 2x plus 3y minus 4z equals minus 11, and then minus x plus 2y plus z equals minus 1, and x minus y plus 3z equals 12. Now again, because we have 3 equations in 3 unknowns, we've got to go through the process of reducing these down to 2 equations and 2 unknowns, which we then reduce down to 1 equation and 1 unknown, and that means it's now solvable. So we've got to go through that process. So I'm going to take, first of all, the most obvious ones. Take equation 2 and 3. Minus x plus 2y plus z equals minus 1, and then x minus y plus 3z equals 12. And immediately the x's are ready for cancellation. So when you go down the columns, x cancels, 2y minus y is y, z and 3z is 4z, and then 12 minus 1 is 11. So there's equation number 1 that I'm going to use. Now I'm also going to take the top one, 2x minus plus 3y minus 4z equals minus 11, together with the second one, minus x plus 2y plus z equals minus 1. And this time I'm going to multiply the second equation by 2. So that means I'm going to get the x's to cancel again. If you get the x's to cancel the first time round, you got to get the same term to cancel the second time round. So that's going to give me a new equation, which will be minus 2x plus 4y plus 2z equals minus 2. And then you go down the columns again, and this time again you'll notice that the x's cancel, and you're left now with an equation that is plus 3 plus 4 is 7y, minus 4 plus 2 is minus 2z, and minus 11 minus 2 is minus 13. And there's equation number 2, which we now take together as a pair of simultaneous equations in 2 variables. Y plus 4z equals 11, and 7y minus 2z is equal to minus 13. Now, the easiest term to cancel here is z, because the signs are already opposed. So if I want to cancel the plus 4z, I've got to multiply the bottom line by 2. And that's exactly what I'm going to do. And let me rewrite these, because I don't want to kind of start writing over terms. So this first equation stays the same, but the second one becomes 14y minus 4z equals minus 26. And again, if I go down the columns, I'm going to get 15y, 4z minus 4z cancels, 11 minus 26 is minus 15, so immediately y is minus 1. And once you discover the value of one variable, by substitution you can reveal the values of the rest. So we can take that now back to either one of these two equations here. Let's take it up to this one. So what's that going to give me? Well, y is now minus 1, so that's going to become minus 1 plus 4z is equal to 11. That means that 4z is equal to 12, which means that z is equal to 3. There's your second one. And then you take both of these back to any of the original equations up here. Okay, so I'm going to take both of those up to the third equation. So my x, now minus y, well, we know the value of y is minus 1, so minus minus 1 is plus 1, plus 3 times z, which is plus 9, is equal to 12. That gives me x plus 10 is equal to 12. X has to be 2. And there's your three solutions. X is 2, z is 3, and y is minus 1. Okay, the graphs of 4 polynomial functions are shown below. Graph A, graph B, graph C, graph D. Here's what we're told next. State which of the graphs above is that of the function x times 1 minus x cubed by 3 minus x to be squared. Okay, now again, this is a kind of a difficult thing to get into your head, because we're only dealing with the x's here to tell me what the graph is going to do. So the first thing I'm going to look at here is when I multiply the x's out, what do I actually receive? There's an x here, that means x is equal to 0. There's a 1 minus x here, which I set equal to 0, and that tells me straight away that x is equal to 1, but it's 3 times. So x is equal to 1 3 times. That's a saddle point. So straight away, if I look up here, I can discount immediately graph B, because there's no saddle point there, and I can discount graph C, because there's no saddle point here. So straight away, it's between graph A or graph D because of the saddle point. 3, of course, let's finish this. 3 minus x equals 0, so 3 equals 0. So here's what I know. The graph is going to pass through 0, saddle point on 1, and pass through 3. Okay, oh, sorry, 3 is there twice, isn't it? So 3 is equal to x there, and 3 is equal to x there. So we've got a turning point on 3. Now, both A and D, they both satisfy that condition. So in order to work out which one we're working with, we've got to take the x's out of this thing. Now, look at what I say in relation to taking the x's. We take the first x, put it in a bracket. Now, in this bracket, it's minus x to be cubed. Minus x to be cubed actually becomes minus x cubed. We're only interested in the x term to tell me which one of the graphs A or D are the right one. And the last one is minus x squared. But whenever you square negative, it becomes a positive. So therefore, this graph we're dealing with is negative x with the power of 6. Straight away, a negative leading coefficient puts the right arm down. So what happens? I can immediately get rid of D, because D doesn't have a right arm down. So by getting rid of D, that means A is the graph that I'm looking for. See that? Now, just to verify the point, if the leading coefficient is negative, the right arm is down. But if the power of the leading term is even, then the left arm is down as well. And that definitely tells me that A is correct. Okay. The binomial expansion, I think, is next. Yeah. Now, in this case here, find the term independent of x in the binomial expansion. All binomial expansions have exactly the same method. All of their terms have a general format. And that general format in this case here is 6c something multiplied by the first term, 2x squared to the power of something, and then 3 over x to the power of something. Now, here's what I want to show you. Look at the two terms inside the bracket. The first one contains an x squared, the second one just contains x. So therefore, the powers that I'm going to distribute must be powers that add to 6, but one is twice the other. So therefore, the only numbers that add to 6, where one is twice the other, are 4 and 2. 4 and 2 is 6, and 4 is twice 2. How do I get 4 and 2? Look at the powers. Here, x squared, and here, x. So that means one of the x's is twice the other one in terms of powers. So therefore, we take 6, we break 6 up into 4 and 2, and we distribute the 4 and 2 in such a way that when they multiply the powers of x, they give you the same answer. So put a 2 here and a 4 here. Okay, now x squared to be squared is x to the 4, and x to the power of 1 to the power of 4 is also x to the 4. So my powers are correct. How do I get the number underneath the 6? Here's the answer. The number underneath the 6 is the number that you get when you take the first power away from 6. So 2 from 6 is 4. And there's a term. Now what I have to do, unfortunately, is I have to multiply this out. 6c4 is exactly the same as 6c2, and then both of these terms get squared. So 4x to the power of 4, and likewise here, both of these terms, the 3 and the x, they both get raised to the power of 4. So you get 3 to the power of 4, which is 81, over x to the power of 4. And immediately, by the powers of algebra, x to the power of 4 that's multiplying, x to the power of 4 that's dividing, they cancel. And what does that leave me with? That's going to leave me with 6c2, which is 15, multiplied by 4, multiplied by 81. And you rush for your calculator and you multiply 15 by 4 by 81, and you get an answer of 4,860. And notice that there are no x's left, so it is the term that is independent of x. Okay, question 4, part A. Examine the graph of the polynomial shown and write down the polynomial for the graph in the form ax power 4, bx power 3, cx power 2, dx and e. Now what they're asking you to do there is to write out the expanded version of the polynomial. And unfortunately, you do not have much choice here. You can't leave the answers as a product of factors. You've got to work out what those factors are. But first of all, how do we get the factors? And the answer is by listing the roots. Okay, so the roots are the numbers that the graph passes through, turns on, or has a saddle point on. So if you take this one here, and here, and here, they are the roots. The graph passes through -2. So x equals -2 is a root. The graph turns at 1. So x equals 1 is present twice. You approach it and you leave it. So it's present twice. And over here, x is equal to 4. Now they're the roots, okay? So what does that mean? It means the factors are x plus 2. Over here, x minus 1 to be squared. And here, x minus 4. So what I now have to do is take the x plus 2, multiply it by the x minus 1 to be squared, and multiply that in turn by x minus 4. A lot of work, yes, but it has to be done. So let's do the binomial first, because we've got a method for that. Let's expand the middle term. We've got x minus 1 to be squared. That gives me x squared minus 2x plus 1, which is multiplied by x minus 4. And again, just take your time. Multiply all three terms here by x. You get x cubed minus 2x squared plus x. Then multiply all three terms by plus 2 2x squared minus 4x plus 2. And all of that still has to be multiplied by x minus 4. So let's just tidy up this first of all. X cubed. Now 2x squared plus 2x squared, gone. Okay. X and 4x, or sorry, x and minus 4x is minus 3x. And then we have plus 2. Okay, so that's the result of that one, which in turn now is going to be multiplied by x minus 4. So again, all three terms multiplied by x gives me x to the power of 4 minus 3x squared plus 2x. Then minus 4 by all of these gives me minus 4x cubed minus 12x. Sorry, plus 12x, because it's minus by minus. So plus 12x minus 8. Let me just check that again. X cubed minus 3x squared plus 2x minus 4x cubed plus 12x minus 8. So tidying these up, what do I get? X to the power of 4 minus 4x cubed. You write them in descending powers of x. Minus 3x squared plus 14x minus 8. And that is the expanded form of the polynomial. Okay, express the following as a single fraction in its simplest form. Now again, notice the presence of powers greater than 1. So immediately we have to factorize. And I would always suggest that you factorize first. So we're going to factorize this quadratic here, and we're going to factorize this quadratic, because they're the ones that are most obvious for factorization. X squared minus 5x minus 14 is x by x, 7 times 2 minus and plus. Okay, this one here, x by x, 7 times 5 is 35, and minus 7 plus 5 is the required minus 2 in the middle. So we're not going to use that, we're not going to use that. A lot of you didn't see the following, that the top term has 5 as a common factor. So that becomes 5 times x plus 5 in its simplest form. And the last thing to remember, if you're dividing by a fraction, that means you multiply by the inverse of the fraction. So now it becomes 5 over x plus 2 multiplied by x minus 7, which in turn is multiplied by the inverse of this thing, which is x minus 7 by x plus 5 over 5 times x plus 5. Now do your cancellations. So let's try for a vertical here, nothing. Anything vertically here, yes, x plus 5, x plus 5. Now do the horizontals. 5 into 5 goes once, 5 into 5 goes once, x minus 7 cancels with x minus 7. And what am I left with on the top? 1, and on the bottom, x plus 2. And that is the answer to that division in its simplest form. Okay, investigate if 3x minus 1 is a factor. Now, if you're asked to investigate, there are a number of ways you can do this. You can punish yourself and go for long division. Or you can remember, if you're testing a factor, you may also test its root. So, if 3x minus 1 is a factor under test, what's the root that comes out of that? The root that comes out of that is 3x equals 1, and therefore x is equal to 1 over 3. Now that's the root. And what do roots do? Roots substitute. So if I take x equal to a third and I plug that into this equation here and it goes to 0, then happy days. It is a factor. But if it doesn't go to 0, it's not a factor. So let's see what happens. 6 times a third cubed minus 5 times a third squared plus 4 times a third plus 5. What does that become? Well, 6 times a third cubed. Now that becomes 6 over 27 minus 5 times 1/3 squared becomes 5 over 9 plus 4 over 3 plus 5. And when you work it out on your calculator, you're going to end up with 6 over 27. So 6 divided by 27. And from that, we're going to take away 5 over 9. So 5 divided by 9. From that, we're going to add 4 over 3. And finally, we're going to add 5. And the answer comes out as 6. Now, what does that mean? That means that the root doesn't fit. That the root, when it's substituted, immediately tells me that 6 is a remainder after division. And if there's a remainder, that means that 3x minus 1 is not a factor. Now, of course, you may go by long division as well and divide into 3x minus 1 into the 6x cubed minus 5x squared plus 4x plus 5. And after your long division, you should have a 6 at the end. Any number bar 0 tells me that the original term under test is not a factor. Given that x squared plus ax minus 1 is a factor of this. Now, given, see the difference? So this thing here is a factor. So what does that mean? X squared plus ax minus 1 is a factor of x cubed plus px squared plus qx plus r is equal to 0. Now, in a situation like that, I think the easiest way to do these questions is by multiplication of the quadratic by a linear term. So look at x squared. To get x squared up to x cubed, I've got to multiply it by x. To get minus 1 to plus r, what do I have to do? Well, I've got to multiply by minus r. Because minus 1 by minus r is plus r. Okay, and they're the only two terms you need to look at. Now, let's multiply out these two quadratic and linear expressions. So we get x cubed minus rx squared plus ax squared minus RAX minus x plus r is equal to x cubed plus px squared plus qx plus r is equal to 0. Now what do they want me to do? They want me to show that q is equal to minus ar plus 1. So we've got to take what we call similar terms from both sides of the equation. So the x squareds and the x squared here, they will be equal. And then the x terms, which are these two here, with the x term here, they will be equal. And then the last constant and the last constant will be the same. They don't tell me anything. So I can ignore the r's and I can ignore the x cubes, which means I've got two equations. Minus rx squared plus ax squared is equal to px squared. And that gives me minus r plus a is equal to p. That's the first one. The second equation with the x's give me minus ra minus 1 is equal to qx. Okay, or 1x I should say. So if you want to get rid of your x's, let's just do that. Let's take the x's out of that one. There should be, actually I'll put the x back in first. There should be an x here. So minus rax minus x equals qx. Now let's take the x's out and see what we end up with. We get minus ra minus 1 is equal to q. So if you take a look up there, what do we have? Well, first of all, look at this one. That there contains all the terms that I need for this. So all I've got to do is rearrange it. Take out the minus as a common factor from both. Minus AR plus 1 is equal to Q. That's exactly what they were looking for. So a little bit of manipulation at the end reveals the answer. Question 6. Given again, given that this is a factor. So what do? The same thing. X squared plus x minus 6 when multiplied by some linear term will give me 2x cubed minus px squared plus qx minus 6. So again, if I want to form a quadratic from a, if I want to form a cubic expression from a quadratic, it has to be multiplied by some linear term. So we do the same thing. Take the first term, x squared multiplied by x, or even 2x, is going to give me 2x cubed. And then minus 6 remains minus 6. Just compare the last term here. Minus 6, that's going to be by plus 1. So all I've got to do now is do this multiplication. 2x cubed plus 2x squared minus 12x plus x squared plus x minus 6 is equal to 2x cubed minus px squared plus qx minus 6. Okay, now again, the 2x cubed is going to tell me nothing. The minus 6 is going to tell me nothing. So the answers are going to come from the x squared terms and the x terms. So what do I end up with? I end up with 3x squared over here is equal to minus px squared. Drop the x squareds. 3 is equal to minus p. Therefore, p is equal to minus 3. That's the first one. And then take the second equation. Minus 12x plus x. That's minus 11x. And that in turn is equal to qx. Drop the x's. Minus 11 equals q. And there's your second answer. Okay, much easier than long division. And in fact, I would always probably say that when you're given factors, particularly factors in the form of a quadratic, the easiest thing to do is to write out the quadratic, leave space for a linear term, and then set it equal to the quadratic. Work out the linear term then by simply looking at the first terms. How do I get x squared up to 2x cubed? The answer is multiplied by 2x. And how do I get minus 6 to stay at minus 6? The answer is multiplied by plus 1. Multiply out the quadratic and the linear, and then you compare your similar terms left and right. Okay, another inequality. So minus 4 less than minus x plus 2 over 3 less than or equal to minus 3. Now, the key thing here, minus, minus, and minus. All terms are minus. But my job is to isolate just that. That's what I want to get on its own. Okay, so the very first thing I'm going to do is I'm going to remove the minus from all terms. So I'm going to multiply across by minus 1. But if I do that, I've got to be very careful, because when I multiply across by minus 1, that becomes 4, but the sign swaps. That becomes plus x plus 2 over 3, and then the sign swaps again, and that becomes 3. And now the difficulty in minus is removed, and all you've got to do now is strip this term down. Step 1, multiply all terms by 3 in order to get rid of the fraction. So you're going to multiply that by 3, this by 3, and this by 3. What happens? Well, we get the following. 3 4s are 12. Then you get that 3 and that 3 cancelling. X plus 2 is left. And 3 3s are 9. And the final thing to do then is to take away 2 from every term. And you get 10, which is x. And then you get 9. So to write this properly, 9 less than or equal to x less than 10. And put it on the number line. What do we end up with? We end up with 9 here, 10 here, and 9 is to be included, 10 is not to be included, and because it's element or, we shade between the two. Okay. Solve the equation. Now we're getting into our Searle equations. The first thing you've got to remember about a Searle equation is this. When surds are involved, they must be separated if there's two of them. If there's only one of them, then you push it over to one side on its own. And this is the case here. The surd is already on its own. So if that's the case, I simply take both sides and I square them. So I square the left-hand side and I square the right-hand side. That gives me x squared equals, when you square a root, they cancel. And you've got a quadratic expression. So now, let's bring the x plus 6 over to the x squared. So it becomes minus x minus 6. And you open your brackets, or else you go to minus b, because you're told to solve, so you could go to minus b if you wished. X by x, 3 by 2, minus and plus, x equals minus 2, and x equals 3. Now, the key thing here with surds is to test them, okay? If I put a minus 2 in there, minus 2 is equal to minus 2 plus 6, so is minus 2 to the square root of 4? Yes. Put 3 in, 3 is equal to the square root of 9, so both answers seem to fit. So you could, okay, that's that one. Next one, a little bit more tricky because there are two surds. But if there are two surds, you're going to square twice. So the first time we square, we're going to square the left-hand side. Oh, apologies, that's my mistake. I forgot to see where the equal sign is. Let me start that again. Because obviously you separate them first. So it becomes root. So root 2x minus 1 is equal to 5 minus root of x minus 1. So the very first thing you do if there's two surds, separate. Once you've separated them and you've got one surd on its own, as I have here on the left hand side, you now square both sides. And you take your time. When you square root, 2x minus 1 stays as it is. When you're squaring both of these terms, you square the first term, 25. You square the last term, x minus 1. And then you multiply these two together as minus 5 root x minus 1, and then you double the result, minus 10 times root x minus 1. Okay, now, step number 2, you now isolate this surd again. Okay, so that means I'm going to take 25, well 25 minus 1 is 24, so I'm going to take 24 from both sides, which gives me 2x minus 25 is equal to minus 10 root x minus 1 plus x, and then I'm going to subtract an x from both sides to get x minus 25 is equal to minus 10 root x minus 1. And the next thing I do is I square again. So I square the left hand side and I square the right hand side, because when there's two surds you're going to square twice anyway. Square this binomial, x squared minus 50x plus 625 is equal to 100 times x minus 1, because you're squaring the minus 10, which is 100, and you're squaring the root, which is x plus x minus 1. So I get x squared minus 50x plus 625 is equal to 100x minus 100. Now, form your quadratic. So you're going to subtract 100 from both sides. That's x squared minus 150x. And you're going to add 100 to both sides, which is 725. And that's equal to 0. And that's the quadratic expression that you're going to use. Now, in this case, I think I'm going to use minus b, because I think it might be just a little bit easier. You've got a as 1. You've got b as minus 150. And you've got c as 725. Let me just think if there's factors. Let me just check. 725. I might do it quicker with factors. I think I have an idea. 725 divided by 25 is 29. That's no good. 725 divided by 725 divided by, let me just check one more and see. 725 divided by 15. 725 divided by, okay, there they are. So I was right. You can open your brackets or you can use your minus b. X and x. 725 is made up of 145 and 5. So x equals 145 or x equals 5. They're your two values. Now again, if we go back up here and see what happens, 145 minus 1 is 144, which is 12, so that fits, and 5 minus 1 is 4, so they fit. So both of those fit perfectly. 145 twice, so 145 times 2 is 290. 290 minus 1 is 289, and the square root of 289 is 17. Yeah, so that's perfect. Actually works. So that's it, because that's 17, and then when you put the 145 in, you get 12. So 70. Oh, sorry, hold on. Try that again. Do both of them. Let me try the 145 first. You bring both of them back up to the original. So 145 goes in there. 2 times 145 is 290. Minus 1 is 289. So I get the square root of 289 plus the square root of 1, which is 12. That should be equal to 5. But obviously it's not, because 17 plus, what's that? 17 plus, oh, that's 16, isn't it? 145 minus 1. Oh yeah, you can't. No, that's not going to work. 144, sorry, 144, which is 12. That should be 144. That's 17 and 12. That is not equal to 5. So let's try 5. When you put 5 in there, we get 3 plus 2. That's it, equals 5. So actually the only one that works is 5. That's way too big. So what you've got to do, you've got to reject 145. Now you just stick them in there in your calculator. Okay, you just put 145 in to this equation up here where x is. It doesn't give you 5. So therefore you have to reject it. There's only one answer to that, and that is 5. Okay. Solve the following inequality. Again, all inequalities finish up on a number line. So you have 2x squared plus 7x minus 4 less than or equal to 0. Again, go to minus b or factorize, whatever you want to do yourself. 2x by x, 2 times 2, all right, 2 times, or 4 times 1, I should say. 4 times 1, that's going to give me plus 8 minus 1 as required. X equals a half, or x equals minus 4. Now, because it's an inequality, they are not the answers. They're the numbers that you place on the number line. Minus 4 and a half. And because 0 is available to me, I'm going to mark 0 in because it's available for testing. 0 is going to be here somewhere. So 0 is available to test. But test where? In the original inequality. You put 0 in for both x's. That goes to 0, that goes to 0, and it leaves me with minus 4 is less than or equal to 0, which is correct. So therefore, and because they're both allowed to be included, because it's a less than or equal to sign, that means that, just change colour here, that the minus 4 gets a dot, the half gets a dot, and we shade between the two. Because again, x is an element of real numbers. Okay. And this one, solve the simultaneous equations. Now this again is an algebraic simultaneous equation where one is linear and the other one is quadratic. Now when we were doing these in class, there was only one way to do them, and that was to rearrange the linear. And then you substitute it into the quadratic. So if I take down x plus 3y equals minus 5 and rearrange it, it tells me that x is equal to minus 5 minus 3y. I just take the plus 3y, I take 3y away from both sides, I should say, and it reveals what x is. Now I don't know what x is as a number, but I do know what x is in terms of y. So I take this new form of x and I put it in here into this quadratic to get 2 times minus 5 minus 3y squared plus y squared equals 41. And straight away I square root my binomial. 25 minus 30y or plus 30y, because it's multiplying minus by minus. Minus 5 and minus 3 is 15, twice that is 30, plus 9y squared plus y squared equals 41. Now multiply everything in here by 2. 50 plus 60y plus 18y squared plus y squared equals 41. And finally, form your proper quadratic. 19y squared, that's those two, plus 60y, and then 50 minus 41 is plus 9 is equal to 0. And again, there's nothing really much that can go in there. So let's see what we can do. 19 nines, 19 3. Let me just see if I can factorize this off the top of my head. So 19 times 3 is 57. Yeah, you can. Now you can go to minus b again if you wish, or you can say the following. It's 19y squared is 19y by y. 9 is 3 3's. Because 19 times 3 is 57, 3 times y is 3, and 57 and 3 gives me the required 60. So what do I end up with? Y equals minus 3 over 19, or y is equal to minus 3. But that's only y. You have an x to deal with, and up here you've got an equation on how to find it. Because x is, bring it down here, is minus 5 minus 3y. That's what I know is the equation. Help me to find x. So now what I'm going to do is put minus 3 over 19 in here. Okay, so that's going to give me y equals minus 5 plus 9 over 19. What's that going to be? Or that's x, I should say. X is equal to minus 5 plus 9, because you're multiplying minus 3 over 19 by minus 3, so that's plus 9 over 19. So minus 5, let's see, 9 divided by 19, and then from that I take away 5, and I end up getting minus 4.52. 4.52. Then over here, this is a little bit easier. You're taking minus 3 and you're putting in here. So that becomes x is equal to minus 5 minus 3 times minus 3. And that becomes x is equal to minus 5 plus 9, which is 4. Okay, so that's your two answers. So the first answer is these two, x and y. And your second answer is these two, x and y. Okay. And that's it. So a quick journey through the exam. They're the solutions as I would expect them to be given. Obviously, there are other ways to do some of the questions. But if you're going through the questions and you want to see exactly how marks were shared out or whatever, or how marks were lost, then any difficulty with any of those questions, just get back to me by email.